So this is a very classic type of problem in this module. You're given 2 points, and we want to find an equation for the line that passes through those 2 points. So our starting point on this diagram here is we're starting in this box where we're given the coordinates of 2 points, and we need to finish up in this box down here at the bottom, having an equation for the line. So we need to get from there to there. So according to this little schematic, starting from the box on the top, what can we do first? What's really the only thing we can do if all we know are the coordinates of these 2 points? We can find the slope. That's the only move available to us, right? We can't move to the right and try to find the y-intercept, because in order to do that, we need to know the slope so that the slope can be a part of that calculation. So the only thing we can do with these 2 points is we can determine the slope of the segment which connects those 2 points. And that we do using the slope formula. So what did you get for the slope of this line? So what did you get for the slope, sorry? Negative 6 over 8. So you got the negative 6 by subtracting negative 4 minus 2, right? Subtracting the y-coordinates one from another. Right, that's the y2 minus the y1. So just to color code this, so that's the negative 4 from here, subtracting the 2 from there. And then you got the 8 from doing what? Yeah, 2 plus 6, which is you got from 2 minus negative 6. So, of course, what you can see happening here is it's going to be very easy. One of the easy mistakes to make in this work is screwing up a sign, as usual, right? So 2 minus negative 6 gives us that denominator. And again, the 2 coming from the x-coordinate of the second point, and the 6, negative 6 rather, coming from the x-coordinate of the first point. So it doesn't matter which order you subtract in the slope calculation, as long as you're consistent, as long as the same x-coordinate lies above the y-coordinate, below the y-coordinate that's matched up with. So one quick check you can do on that is just looking vertically in the fraction that you wrote down, and just making sure that the x-coordinate and the y-coordinate of the original points are indeed one above the other in the formula that you wrote down, so that you're not getting it crosswise. And yeah, sure enough, when you carry out that calculation, you get a negative 6 on the top, you get an 8 on the bottom, but that's a fraction that's not completely reduced. So how do I reduce that fraction? Yeah, just divide the numerator and denominator by their greatest common factor, which is 2, to get negative 3/4. Great. So according to the work we've done so far, we know that the slope of this line is negative 3/4. So that lets us do 2 things. It lets us go down to this equation template down here at the bottom and replace the slope where the m resides in that template. So I'm going to just go ahead and do that right now. Negative 3/4 goes in where the m goes. And the other thing that allows us to do is now to use that information along with our points to find the y-intercept. And again, as I mentioned before, that's the step where people get hung up. And I saw a couple of your groups get hung up at exactly that step. What do I do now? Because what you did, if you got stuck there, is you said, all right, we have this equation template now. Y equals negative 3/4 x plus b. Because we found out what our slope was. But then you sort of start staring too long at that, and you're like, well, what in the world does that do? What can we do with that information? So what can you do with that information? With y equals negative 3/4 x plus b, where did you go from there? How do you keep advancing in your quest to discover an equation for this line, which at this point, all we need in order to discover that equation is to figure out what b is. Right? As soon as we have what b is, we can just plug the b in and be done. So how do we use this equation to tell me what b is? What information are we lacking? Say again?
Use one of those.
Yes, right. So according to our little schematic, we put the slope in for m, but to figure out what x and y are, we can use either one of our original points. So we can go back to the well, back to the original problem again, and use either of the 2 points, which we know to be a part of this line, as the x and the y. So I suppose I should add to this schematic. Plug in any known point as x and y. Which point did you choose if you were working this problem? When you were doing this one, which one did you choose? First one? So negative 6, 2? Yeah. Again, as long as your slope is correct, it won't matter which of those 2 points that you pick. So let's pick the first one. If I pick the point negative 6, comma 2, then I'm going to put a negative 6 in here where my x was, and a 2 over here where my y was. So 2 is equal to negative 3/4 times negative 6 plus this mysterious b, which we don't know, but which we're about to know. So now all I have to do is solve that equation to get b. What's negative 3/4 times negative 6? Again, don't... Yeah. Because when you're multiplying fractions, we turn the negative 6, the integer, into a negative 6 over 1, and then multiply straight across these two to get an 18 on the top and a 4 on the bottom. Yeah, we could also have cross-reduced first if we wanted to. Whichever road that you take to get you where you're going on this, now we can reduce this fraction by 2's and get 9 over 2. And then our last step to get the b by itself is to subtract 9/2 from both sides. And to subtract 2 minus 9/2, I have to change 2 into a fraction with 2 as its denominator. And then subtract across the numerators. What's 4 minus 9? Negative 5. So according to all that work, the y-intercept of my line is going to be the point 0, comma, negative 5/2. And now that I know that, how do I finish my equation? Yep, take that negative 5/2 and put it into my b. So my final equation here is negative y equals negative 3/4 x minus 5/2.